Hello students, I am Deena. Welcome to Math Fam. So today we'll be taking here circle theorem, which is very important topic. So what are we going to cover in this chapter? Circle theorem. If you will see first, we will see what are the arc properties. So there are three theorems based on arc properties. Then you will learn the tangent properties of the circle. Then again there are three theorems properties that you need to remember related to tangent property. And then you will learn chord properties, again three theorems based on chord properties. So before we start these theorems, first thing, some basic things you should know here. So if I take here circle and its parts, right? So first you have to be aware about circle and its parts, because you will be using these parts to solve the questions, right? So how are we going to take it? If I take a circle here, now you know that here this is, there has to be a center. Now if I join from the center to the circumference, this is called radius. And if I extend it passing a line, a chord passing through center, it is called diameter. So diameter is nothing but here double the radius. Right, now any two points you join on the circle, that's called chord, and the longest chord is called diameter. So CD, it is a chord, right? This is a chord. Now what do we call segment? Because here segment means the area occupied between a chord and an arc. So what is the arc here? If you see, this arc is a piece of circle. CD is known as arc, which is the part of circumference, right? So this is arc, and the area enclosed between a chord and an arc is called here minor segment, because it is less than semicircle, and if it is more than semicircle, then that's called major segment. So if I'm taking here major segment, if I take this whole part will be taken as here major segment, right? All these things you have to know, because when you're solving the questions, you must remember all these parts. Other than that, you must have heard about the sector. So sector is nothing but if you take two radii, this is OB is one radii. If I take one more point here, if I take this as E, you can see that the OE and OB are the two radii, and this is one arc which is BE arc. I can take it here BE, which is a minor arc, right? And if you are taking the area enclosed between two radii and one arc, will become here your minor sector. Okay, so here that will become minor sector. So whatever is the remaining here more than semicircle, that is going to become your major sector. Okay, so this is there. Then other than that, because we'll be learning theorem, how the angle, because most of the time you'll be finding the measure of unknown angle or sometimes sides, right? So here if I say angle subtended by an arc, angle subtended, so what is this word? Subtended means made by, okay, by an arc or a chord. A chord. What does that mean here? If I'm taking this, I have to take a circle, and if I'm taking any arc, right? If this is a center, now you know that arc is nothing but when you take here any 2 point on the circle, this length is called arc, right? So, and what is this? AB is a minor arc, and if you will see, what is the angle subtended by AB at center? Okay, here at center, or you will see that any point on the circumference, any point on the circumference. So if I take this, what we will take it here, now you will take the end point of the arc and join through the center. So OA and OB, A and B are the end points of the arc, and if you join this is called angle subtended by AB arc at the center. So here AOB, angle AOB is angle subtended here by arc AB at O, which is the center. Now if I join this, then it will be the angle subtended by chord AB, because you will take for angle subtended by chord or the same arc, it is going to be the same, because AB is a chord. What is the angle subtended by this chord at the center? That is also angle AOB. Right now, same thing, this is at the center. If I take another point here on the circle, right? Now, AB arc, if I join A to P, okay, and here B to P. Now you can see that here this angle is going to be, this is called here angle APB is the angle subtended by again arc AB only at P, which is on the circumference, because P is a point on circumference. So we'll say it is on the circumference, at a point on the circumference, right? So this basic you have to know. Let us start with the circle theorems now, because whenever you start circle, first you should know about these parts, and then here we'll start with circle theorems. And first we will see the circle theorems based on arc properties, because I told you here first we'll see what are the arc properties. So there are three theorems: central angle theorem, angles on the same segment, and angle on a semicircle is 90 degree. So let us start with the first theorem here. If I take this is our first theorem. Okay, this is called central angle theorem. This is your first theorem. There are 9 to 10 theorems that you use it here. Now, what is the central angle theorem? What you will not write down central angle theorem, but though we know this theorem as central angle theorem, it says angle at a center is twice the angle at a circumference. Now, angle at a center means here you can say that angle subtended by an arc. Okay, subtended by an arc at the center is twice the angle at the circumference. Now, just now we are seeing this. What is the meaning of angle subtended by an arc? So, if I take here O, here if I take arc AB, angle subtended by arc AB at the center O is going to be angle OAB, AOB. This is angle BOA or angle AOB. Now, here it's written twice the angle at the circumference. That means you can take any point other than this arc on the remaining part of the circumference, because this is the angle subtended by AB arc, so I can't take any point on AB. So if I take here another point here P, and this angle APB is going to be half of the angle AOB, or AOB is double of angle APB. So how will we write down here? Angle at a center, which is angle AOB, is twice the angle or double the angle, 2 times angle APB. This means if this angle is X, then this will be 2X. If this is 50 degree on the circumference, then at the center it is going to be 100 degrees. So let us see one example based on this theorem. We'll be seeing each one example, and at the end we'll be discussing here exam type questions. Okay, so this is your one example question here. If I take it here, what does it say here? Now if you see, say what is given, angle ABO is 50 degree. Angle ABO, it's already marked here as 50 degree. We need to find out here angle BCA. Now this angle, how are we going to find out here? Remember, whenever we take a circle, you should know, you will always, because in a circle, if I take any triangles made by two radii, if in that triangle, if two of the sides are radii, you will always get isosceles triangle, right? Here also AB will be equals to OA will be equals to OB, right? And this is the base angles are equal, because angle opposite to the equal sides are equal. So this angle and this angle also, they both will be 50 degree. So angle AOB at the center, using angle sum property, you know that it will be 180 minus 50 plus 50, which is going to be 80 degree. And if we use this theorem, because see, if you will see, this is chord AB or arc AB subtending at the center angle 80 degree, right? This angle is 80 degree. That is going to be, that is twice this angle, or angle ACB will be half of this angle, because this angle is double of this angle. So how are we going to take it here? We can write on using central angle theorem, or you need to write on the full statement. angle at the center is twice the angle on at the circumference subtended by any arc. So you can write down here angle here ACB will be half of angle AOB. Or what have we learned here? Angle AOB is double the angle ACB, and I need ACB, so I transpose to this side. That's why I'm writing here half of AOB, because we have the measure of this angle which is 80 degree. So what is going to be the measure of angle ACB, which is half of here if I see 80 degree, that is going to be 40 degrees. So your answer using this first theorem, we will get the answer as 40 degree. This is the next theorem which states that angles on the same segments are equal. This is theorem 2 based on arc property. Now, what is the meaning of segment? Because see, I was telling you here it is on the same segment. So, any chord and arc divides it into two segments, right? So, anything. So, this is going to be called minor segment. This is called major segment, right? This part is major segment. So, what does it say here? Angles on the same segments are equal. So first let us take a circle. Again your arc is going to divide your circle into two parts. So this, if you will take this is your minor arc, right, which will give you here minor segment, and the other part, the bigger part, which is having the longer arc, that is going to be called as major segment, right? So either you take here minor arc and this is your major arc. Now it's written angle on the same segment. So again the angle will be subtended by any arc. So take any 2 points here. Okay, if I take here point AB and if I join these endpoints to get angle A and here angle B from P and Q, because endpoints are P and Q. So these two angles are always equal. So we can write down here it is the angle subtended by, if you see this angle is subtended by arc PQ on the minor segment. So these you can take any number of points here, not only two. All these angles are going to be equal. There are infinite points. I can take those infinite angles. I can take here one more point here. See. So if you are taking here angle PCQ, this angle also will be equal because all these three angles are on the same segment. So what can I write down here? If I am writing here angle PAQ will be equals to angle PCQ will be equals to angle PBQ. It's called angle on the same segment. Similarly, if I take any points here on the minor segment, if I take this as x and this as y, again the arc is PQ only. Angle subtended by PQR at x and angle subtended by PQR at y, both the angles are on the minor segment. So this angle will be equal to this angle. Similarly, I can take here any number of points on each of the segment. Angles are going to be equal. So here what is the on the minor segment, I can write down PXQ will be equals to angle PYQ will be equals to angle PZQ. Only remember x cannot be equals to angle C. You can't take any angle. This is the two segments, right? So any angle on the same segments are equal. So minor segment or major segment, all the possible angles are going to be equal. Let us solve one question. How do we use this theorem to solve the question? Let us see one example question. We'll be taking all these example, each theorem based example, and then we'll see the exam type questions. Okay, so this is what is given here in this question. If you'll see, given that BDC, angle BDC, it's given 62 degree, DCA, which is 44 degree, I need to find out angle BAC. So what is angle BAC? This angle, and ABD. ABD is this angle. How are we going to do it here? Now first you have to identify how the angles are formed. By angle subtended by which arc? So how can you do it here? This is angle 62. You just see that where the arms of these angles are made here, ending here. Endpoints, if you'll take it, you will get to know it is subtended by which arc, because we have to use angles on the same segments are equal. So what is your 62 degrees subtended by arc BC. Here, if you see here, this is arc BC. Now, do you see any other angle subtended by BC? Take the end point B and C and see how it is gone to the other point A. So, 62 degree, this angle also will be 62 degree. So, your angle BAC will be 62 degree, and reasoning you have to write down angles on the same segments are equal. Angles on the same segments are equal. Whenever you are using any of the property, you need to mention that, okay, are equal. So this is your then similarly here, if you see 44 degree angle is subtended by which arc. So take 44 degree, these are the two arms of the 44 degree angle, which is CD and AC, and AD, it is ending at A and D. And if you see the arc, this is AD arc is subtending angle 44. Do you see any other point where AD subtend the angle? So take the endpoints A and D and see which line segments are passing through these two, which is this angle. So here you will write down angle ABD as 44 degree using the same theorem. So this is the way we use angles on the same segments are equal. Let us go for the next theorem. So our two theorems based on this one arc properties, it is done because we have taken the arc only. This is your theorem 3. Angle in a semicircle is always 90 degree. This is your third theorem. This is theorem, you have to remember all the theorem statements so that you can use wherever it is required. So angle in a semicircle, first if I take a circle, you know that circle will be divided into semicircle by a diameter. So if I take here AB as a diameter which is passing through center O. Now AB chord or AB diameter is dividing this circle into two semicircle. Now they are saying angle in a semicircle is 90 degree. That means either part you take, because both sides, this is also semicircle, each half is representing semicircle. This is also your semicircle. Now angle at a point, because angle, if I take this point as here P, and anywhere on the semicircle if I take it as Q, now the angle will be subtended by this arc AB or chord AB or diameter. So take A to P and B to P, you will see this angle is always 90 degree. Similarly, if I join A to Q and B to Q, this angle is also 90 degree. Now I can take any point here, any angle subtended by the same diameter, it is going to be 90 degree, because you have seen that angles on the same segments are equal. So angle APB will be equals to angle AQB. Here they are equal because each angle is 90 degree. Now you can see that all the three theorems based on arc properties are here done, and now we will see what are the properties or what are the theorems related to tangent. So these are called tangent theorems. So again you will see here theorems based on tangents. Theorems based on tangents, right? What is the meaning of tangent? Before we go for the tangent theorem, theorem based on tangent, we should know what is the meaning of tangent, right? So tangent is nothing but a line or line segment touching circle at only one point. A line which touches circle, it can be line segment, it can be ray, it can be any line also which touches a circle at one point only. Otherwise it will be known as secant if it is cutting at two places at one point only, and that point of contact we uh, touching point, which is wherever the tangent touches the circle, that's called, it is at only one point, which is point of contact, which is point of contact. So first you should know what is the meaning of tangent, then you can use tangent theorem. So let me draw here. If I'm taking a circle, right? If I'm talking about any line, so this can be any line, because you need to, because it's going to touch circle at one point. So this is, if P is a point, this is center, you can see that OQ is a line or OQ is a ray, right? Now again another one here, if this is a circle, take any point here X. Now you can say that here AB is a tangent. AB is a tangent here. AB is tangent which is touching circle as at X, touches circle at X. So X is known as point of contact. Here your point of contact is P only. So how many tangents you can draw on a circle? I can draw here infinite tangent, because there are infinite point on a circle. So you can draw infinite tangent, but at a point there will be only one tangent, right? If I am touching, if a line is cutting here circle at two places, then this is not a tangent, this is called secant. Okay, we are not going to talk about secant, or this is a chord extending it, then we call it as a secant. This is your theorem number 4. Now what is written here? Angle between tangent and radius is always 90 degree. So first, if I take a circle, right, there is a center. What is written? Tangent and radius. So first you draw a tangent. If I am drawing tangent here, which is AB at P, AB is a tangent and the point of contact is P. So here angle between tangent and radius, and how the angle will be formed here, if I take the center and through the point of contact. So angle between, at, you can write down here point of contact, because your 90 degree is going to be made at a point of contact. Now either side, whether you take angle OPB or angle OPA, here angle OPB will be equals to angle OPA, because either side it is there, it is always 90 degree angle. If I take another circle and if I'm having here, you can get, now you should know the Pythagoras theorem also, because when you are having 90 degree angle, here see it's P and Q. Now PQ is a line segment and PQ is a tangent at P. Now if I take this, you can see that if I join this, you will get a right triangle. So again your trigonometric properties can be applicable. You should know the Pythagoras theorem also can be applicable to solve the question. So this is again very important theorem. Let us see one example based on this. Here you need to find out the unknown angle. Here you need to find out angle A. Now you know that the tangent AC is a tangent at R, right? So here if you know that, you will use the theorem. The tangent is always perpendicular to the radius. So here there is a 90 degree angle, and using, because triangle ORC, if you use angle sum property, 90 degree plus 4A plus A will be 180 degree. So 5A is 90 degree, 90 minus 180 minus 90. So A is going to be 90 by 5, which is going to be here 18 degrees. So your angle A, angle A, which is angle C, it is going to be 18 degrees. This is your theorem number 5, which says that here tangents from an external point are equal in length. First thing, you should know how many tangents you can draw from the external point. So if I take a circle, right? Now this is a circle, an external point means anywhere outside this circle. So if I take a point P, now how many tangents you can draw to the circle here? You should know there is only possibility of two tangents through this circle, right? From P, I can draw only two tangents to the circle. There are no more than two drawing. It's not possible to draw more than two tangents to the circle. Now, what is given here? They are always equal in length based on this theorem. Tangents drawn from the exterior point P are always equal in length. So PA is equals to here PB. This we can use it. But why is it true? We can prove any of these theorem using congruency here, because you know that the radius is perpendicular to the tangent is perpendicular to the radius. So I can draw here two radii here, which is OA and OB, and this will be 90 degree and 90 degree. Now if I divide it into two triangle OP, you know that OP is the hypotenuse common side and the radii will always be equal. So here, why do we say that tangents are equal? Using congruency. This is common side. So I can say that here triangle PAO is congruent to triangle PBO using which congruency here? RHS congruency, right angle, hypotenuse and side. Therefore, PA is equals to PB. Now, how will you use this theorem to solve the questions? You know that this is tangent drawn from T. T and TB are tangents to the circle from point T. So, they will be equal in length. Now, what do I need to find out? Angle ABT. ABT, this angle, right? Now, you know that angle opposite to equal sides are equal. So, this will be X. This also will be X. So you can take it here. If I'm using angle sum property in triangle TAB, you know that it will be 2x will be 180 minus 50 and 2x will be equals to 130 degree. So x is going to be here 65 degree. So your angle, your x I have taken, this is nothing but angle ABT. So which theorem are you using? Tangents from the exterior point are equal in length and you are getting isosceles triangle, and using angle sum property you are getting x. Other than that, how to find out measure of angle AOBA? This angle, how will you get it? You know that tangent and radius, tangent is perpendicular to the radius and this is OB is the radius, so I can take it here OB perpendicular to BT using the previous theorem, theorem number 4. Now it is 90 degree, we are already having 65 degree. So angle OBA will be equals to 90 degree minus 65 degree, which is 25 degree. So this theorem 6, this is called alternate segment theorem, and you can use this word name also, alternate segment theorem. Now what is the meaning of alternate segment theorem? It says the angle lies between the tangent and a chord is equal to the angle subtended by the same chord to the alternate segment. So first let us draw whatever they are saying here. If I take a circle, this is a circle with center O, angle lies between a tangent. So first you draw a tangent here. If I take here PQ is a tangent at P and here PR is a chord. So what is the angle between PR and PQ? This angle is, if I take it as theta. So now PR is dividing into two segments. This is one of the segment and this is another segment, right? Now on the alternate segment, because I cannot take anything on the minus segment, any point you take it here, right? Anywhere on the remaining part of the segment here, when you join the endpoints of this chord, this angle will be PXR, also will be theta. I have marked here theta, so it's easy to do the comparison. So angle between the chord and the tangent is always equal to the angle subtended with the chord on the alternate segment. So here I can write on angle QPR will be equals to angle PXR, which is nothing but theta. How do we use this theorem to solve the question? Let us see one question. What does it say here in this diagram? The angle ATS. If you see here, we need to find out angle ATS and angle TSR. So this angle ATS and TSR is this angle is also unknown. How will we find out this? The both the angles. So always go known to unknown angle, right? So here angle using alternate segment theorem, you can see that 70 degrees made between the tangent and the chord TR. And is same as this. So angle this is going to be 70 degrees. So angle TSR is going to be 70 degree. And once you have this angle 70 plus 80 degree 150. So within this using angle sum property, your angle ST R will be 30 degree if you are using angle sum property. And to find out this exterior angle, I can take angle on a straight line sum up to 180 degree. So angle ATS plus angle STR plus angle BTR, all together it is 180 degree. You already have here the 70 degree, this is 30 degrees, so this angle together it is 100, this angle will be 80 degree. So your angle ATS is 80 degree using angle on a straight line. Or if you'll use, see there are different ways. Now if you will see, this is also the angle subtended between the chord and the tangent from this side, right? This side, either side you can take it. If I don't want to take this, then here if you will take it here, both ways you can use alternate segment theorem. See, this is angle between tangent and chord TR, so this will be 70 degree, and angle ATS is the angle between chord TS and this, which will be equals to 80 degree. Then you, this angle, if they ask you to find out, it will be 30 degree. So in geometry you will see the different ways to solve the question. It's up to you. Remember all the theorems, so it's helpful to solve the question. Let us go for the next set of theorems, which is based on chord properties. Theorem number 7, it is based on cyclic quadrilateral. So again, before you take the theorem cyclic quadrilateral, first you should know what is the meaning of cyclic quadrilateral. This is theorem number 7. So when you cyclic quadrilateral means when you take any 4 points on the circle. So here if I take here a circle, right? Now cyclic quadrilateral any, because whether there is a center or no center does not matter. I can take any 4 point on the circle, and if I join those 4 points, whatever quadrilateral I get it, that's called cyclic quadrilateral. If you'll see, can you see here ABCD? It's called cyclic quadrilateral. Now, what is the property given there? Opposite angles of a cyclic quadrilateral is always supplementary, or they add up to 180 degree. That means if I take angle A and angle C, that is going to be here angle A plus angle C, it is going to be always 180 degree, and angle B plus angle D is also 180 degree. Sometimes we use here converse also. So if the opposite angle in a quadrilateral, if opposite angles sum up to 180 degree, we will say then it will be cyclic. So you use sometime vice versa also. Says here find out H, right? Now where H is marked here, H is marked here in the figure here. Now what is always go known to unknown? Now this is your 106 degree, and you can see that it is forming the linear pair with angle BCD and DCE. They both are linear pair. Linear pair means angles sum up to 180 degree. So how to get this angle here? 180 minus 160. If I do it, I'll get it here 74 degree as this interior angle. Now using this theorem, you know that I can find out here angle BAD. So if I take here angle BAD, because opposite angles of a cyclic quadrilateral is always sum up to 180 degree. And first you can see that why can I use this theorem, because ABCD is a cyclic quadrilateral. So you can start with that also. ABCD is cyclic quadrilateral. So any property which is related to cyclic quadrilateral, I can use it. Okay, so angle BAD will be equals to 180 minus 74 degree, or which is 106 degree. So sometime because you have extended this angle, so this exterior angle will always be equals to opposite interior angle, right? So this angle is 106 degree. Now 100, after getting 106 degree, you can see that there is isosceles triangle symbol. So this angle, because angle opposite to equal sides are equal, so H also will be there. So 2H plus 106 is 180 degree, and if I take 2H will be 74 degree, so H is going to be here 37 degree. So this is, we use here oppose cyclic quadrilateral property to find out the unknown angle. Now what is the next theorem here? Theorem number 8, it says the perpendicular bisector of a chord passes through the center, or you can take its converse also, that the perpendicular from the center will bisect the chord here, right? So what does it say here? Perpendicular bisector of a chord. So first I'll take a circle, right? This is a circle with, if I take here center O and a chord AB. Here if I take here chord AB. Now perpendicular bisector means if OP is perpendicular as well as bisects AB. This means here OP is perpendicular on AB and AP is equals to BP, or P is the midpoint of AB. Now it always passes through the center. That means whatever the line is, this one is passing through center O. Or if I draw a perpendicular from the center to the chord, it will bisect the chord. How do we use it to find out the length? I can join AO or OB also. You can see that it's a, you can use here Pythagoras theorem to find out the unknown length, or to unknown angle also we can use it. Now what is given here? It's written here find x. Now you can see that, because if I take this as AB chord and here it's a PB, you can see that AP is equals to BP. That is why I was telling you, you can use, you can use sometime converse also, because AP is equals to BP, and this will be true only when OP is perpendicular on AP, because only perpendicular from the center will bisect the chord. So therefore I can write down OP is perpendicular on AB. So if OP is perpendicular means angle OPB will be 90 degree, and here it's given in triangle. If I take here POB, 80 degrees central angle at a center, then angle POPB is 90 degree, plus x will be 180 degree. So x value is going to be 10 degree. This is theorem number 9. If I take here theorem number 9, what is written here? Equal chords are equidistant from the center. That means here if I take a circle in any two equal chords, so here if O is the center, if I take here AB is a chord, equal chords. So what is given here? AB is equals to CD. It's given. AB is equals to CD, right? It's given that AB is equals to CD. Then what is, as per this theorem, distance means it's always perpendicular. So if I see that OP is the distance of AB from O, so this is OP, and if I take here OQ, that is the distance of CD from O, from the center, right? And this is also perpendicular because it's a center. So you can say that here OP will be equals to OQ, or if the distance are equal, then the chords will be equal, because these theorem you can use their converse as well. Okay. So these, and how do we use this theorem to solve the question? One example here, if it says here, what is the length of AB if CD is 8 centimeter? So CD it's given here 8 centimeter. Now here there should be 90 degree, because you can see that the distance OP is equals to OQ, right? So if, see, this is your converse, OP is equals to OQ, then your chords are going to be equal using this theorem only. Equal chords are equidistant from the center, or if there are two chords which are at the equal distance from the center, then the chords will be equal in length. So then AB will be equals to CD, that is going to be 8 centimeter. Now let us see the exam based question here. This is the first question. Now all the diagram or figures are not to scale. What is written here? C is the center and angle at a center, it's given here 150 degree. The length of the chord, if I take this as a chord, AB chord, it's given as 5.4. I have to find out the radius. You need to show that radius is 2.8 centimeter. Now if you will see here, if you observe this triangle, you can see that this is going to be isosceles triangle. Let me here redraw this triangle so that easily you can understand how are we going to take this. Now I'm just taking here CAB, and here it's written this side will be equals to this side, and if I draw the perpendicular, it will bisect the opposite side, because it is uh, isosceles triangle, right? And we know that if I draw the perpendicular, both the triangles are congruent. So each angle is going to be 75 degree, because here if I take here P, then triangle APC will be congruent to triangle BPC. Using, you can take red eye are equal, so I can take here right angle, hypotenuse and sides are equal. Now the moment you get this, because it is bisector, each side 5.4 by 2, which is going to be 2.7. So each side, each part of this line segment will be 2.5 centimeter. Right now, each here given, though it is a part of circle here, but we are using here trigonometry, because in triangle, if you will see APC, I can use trigonometric ratio opposite by hypotenuse, which is going to be sine. So sine 75 will be equals to 2.7 by r. R will be 2.7 by here sine 75, and if you will check that 2.7 divided by sine 75, you will get it as 2 point, which is given as here 2.7952 centimeter, which this is equals to approximately 3 significant figure will be 2.80 centimeter. They are not telling you to find out here the length of this line segment, right? But if I add the extra question, can I find out the length of these two tangents? Because if you see, these two tangents are always equal in length, right? So I'm just adding one more extra question also here. Find out here length of tangent, because that kind of question also you will see in exam. How will you get it? Now you know that if you will see PACB is a quadrilateral. So what will be the angle this angle will measure, because opposite angles are supplementary. Here each angle is 90 degree, right? And if I join this to this, again you can see that here triangle PA C will be here. I can't take here P because I have taken this point as P. So let me take it as Q. So it is QAC will be congruent to triangle QBC, using again RHS. You can take it. Now each angle of this part, it is going to be 15 degree, right? Again, because both the triangles are congruent. So again here 15 degree, opposite side is known now here 2.8, right? So I can, radius is known. So what trigonometric ratio I can use to find out this here? Opposite, and because this is, remember here QC is going to be hypotenuse, because opposite to 90 degrees hypotenuse. So AQ, to find out AQ length, you will use tan, because here tan 15 degree, opposite is 2.8, and adjacent is, this is R by AQ. So 2.8 by here AQ length we don't know. So here AQ length is going to be 2.8 by tan 15. And if you take that here 2.8 divided by here tan 15, if you do it, you will get 10.4 centimeter till 3 significant figures. So you can find out the length of tangent after finding the radius. This is your first question. Now let us go for the second question here. Now here I need to find out the tangent, means equation of tangent. I have to find out here equation of tangent. And whenever tangent, if you'll see, it's a straight line, so you'll use here y is equals to mx plus c. I need to find out gradient and y-intercept. So first let us see how will we do it here, because gradient I can't directly find out, only one point P is known. And how do we get here gradient? One method is y2 minus y1 by x2 minus x1, but there is only point P, so I cannot use directly. So what theorem we'll use here? You know that O is the center of the circle and tangent is perpendicular to the radius. Now if you see that OP is the radius, right? This is your R. OP is the radius. So here OP is perpendicular to, if I write on here, PT. That is your first theorem. So PT, so the product of their tangent, their gradient is always going to be -1, because they are perpendicular to each other. And how to get the gradient of OP here? If I find out here gradient of OP, because O is nothing but here centers, which is the origin in the graph form. So O will be 0, comma 0 and P is 4, comma 3. And if I find out here gradient, which is M1, it will be 3 minus 0 by 4 minus 0, which is 3/4. And the tangent is perpendicular, so I can get M2 as minus 4 by 3 using this rule. Now, how to find out the equation? Now, I am having here M2 already, it's there. So, I can substitute here equation of tangent is going to be here minus 4 by 3x plus c. Now, c y-intercept we don't know, but p is a point on this line. So, I can substitute 4, comma 3 to get the value of c, which is going to be into 4 plus c. So 3 plus 16 by 3, which is equals to c. C will be, if you find out the LCM, 9 plus 9 plus 16 is going to be here 25 by 3. So what is going to be equation of tangent passing through P is going to be y equals to minus 4 by 3x plus 25 by 3. Right? This is the answer. So here your coordinate geometry topic and circle theorem, that theorem both are integrated. Right? So here we got this. Let us go for the next question. This is to find out the unknown angles. Always remember you have to go known to unknown. What is given here? A, B, C, D and E are on points on the circle. AC is parallel to ED. So always read the question carefully. Now whenever there are parallel lines, all the theorems related to parallel line, cut by a transversal, all those things you can use. Now first thing, 70 degrees known, 34 degrees known, right? Now, do you see that 70 degree is made by arc AD, right? Now, you have to observe, does arc AD subtend any other angle, which is X, correct? So, your first finding will be here, this also will be 70 degree. So, here X is going to be 70 degree. Why? Because angles on the same segments are equal. On the same segments are equal, right? Always remember the properties, wherever required you must write down. After that, how to find out y? Now you know that y is the part of the small triangle, which is AED. And if you will see your AEDC, this is a cyclic quadrilateral, correct? Or I can take this is a cyclic quadrilateral. I'm taking 70 degrees the complete angle, so this angle is going to be here 110 degree. But we need to find out here why. Now you know that something else is also given here, parallel line, and you know that parallel line is this, and what can be the transversal here? If I take this, this is a transversal, and alternate interior angles are equal. So this angle will be equal to this angle, which is going to be 34 degree. So you can use then in triangle AED, then y will be equals to 180 degree minus 34 plus 110 degree, which is 180 minus here 144 degrees 50, it is going to be here 36 degrees. So your y value is going to be 36 degrees. Let us go for the next question. Right, what do I need to find out here? Read the question carefully, because you always go known to unknown, right? Here this is the given information. Right here, this is the given information. And what is the first question we need to find out here? Determine the password. That's the question here. Now let us read this question carefully. What is given here? There is a circle. You can see that A, B, C, D, E. There are 5 unknown angles. So what is given here? A mathematician decided to put her password inspired from the following math problem. Now the password is 8 characters long. First 3 characters. So there will be 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Now this first 3 places, first 3 alphabets from the spelling in English of angle A. If you will see angle A, you see that how the angle, because here there are many unknown angles. So I'll take this angle, I'll see its arms, right? So I'll understand it is made by chord AB. Now this angle, there is one tangent also, right? So 63° is this angle between the tangent and the chord, and the angle made by the same chord on the alternate segments is equal. So this is going to be your here 63. A is going to be 63° using which angle here? Angle A is 63° using alternate segment theorem, right? You should know which theorem we are using here, alternate segment theorem. Now what is going to be here? Three letters of the angle, first three alphabet from the spelling of angle A. Now 63, so first three letter it is going to be here X6, right? And after that what is written here? Our first part is done. Now it's written fourth character is second digit of angle B. That okay, this is your angle B, which is subtended by AB and BD. These are the two arms of the angle, that means arc AD. Now arc AD is subtending angle at C also, which is 19°, and angles on the same segments are equal. So B is going to be equals to here 19°, right? So this is your first finding. B is 19° using angles on the same segments are equal, right? Angles on the same segment are equal, right? That is there. So what is the second digit? Because they are not talking about the letter here. First here it was characters, so you take alphabets. Here you need to take the second digit. Second digit is 9. So my password, it is 6 and then 9. After that, fifth character, fifth alphabet from the spelling of angle C. Now look at here, angle C is the part of triangle here AOB, and I am already having B. So this angle we can get it in isosceles triangle. For that, first you need to get angle E. How to 48 degrees subtended by, look at here, 48 degree is subtended by DAC, means this is the chord. This is the arc. Now this arc is subtending this angle as well. That means sum of C and D is going to be 48. C plus D is 48 degrees. This is arc AB is subtending angle at the center. It is subtending angle on the circumference at D and as well as C. So how to get it here? Can I find out this angle using angle sum property? So in triangle ADC, if I take it here, angle, this angle will be half of E, right? Or central angle, because we need to first find out to calculate C, I have to find out this. So how are we going to get it here? I can take it here, angle ADB using angle sum property for triangle ADC, 180 degree minus 19 plus 48 plus 63 degree. If you add these three and subtract from 180, how much will you get it? Minus 48 minus 63, it will be 50 degree. So this angle is 50 degree here, right? This angle you are getting it as 50 degree, and double of this is going to be central angle. So here your, this is your 50 degree, and angle E will be double of this, because central angle theorem, angle at a center is double of angle at the on the circumference. So 100 degree is E. Now if you take in triangle AOB, because you know that OA will be equals to OB, this is the radii, so base angles are equal, that is 100. So each of this angle is 40 degree, right? So angle here OBA will be equals to 40 degree, because if I use angle sum property, this is 100, each one, this side 40, this side 40. So B plus C is 40 degrees, and B we are already having it as 19 degrees. So C will be 40 minus 19, which is going to be 21 degrees. Right here. Then C, once you get it, you can find out D also. So D will be 48 minus 21, which is going to be here 27 degrees. Right. After that here to, we are left with E also, we got it here. I think so. We got all the angles, unknown angles. So let us see how the we are going to make the our character. We are done with 2 bits. Third one says fifth character. Fifth alphabet is the fifth alphabet from the spelling of English of angle C. Now angle C, you are getting it as 21, right? So if I write down here 21, they are saying fifth alphabet 1, 2, 3, 4, 5, which is going to be T, right? So this place you are going to fill with T because it's a fifth alphabet. So that is going to be T, and so I can write down here small t because it's written here alphabets in small. So this is T, right? And then after that here sixth character, it is sum of digits in angle D. Now how much did you get angle D? 27, and sum of digits 2 plus 7, which is 9, right? So here you will write down next place 9. Now last two characters, last two digits of angle E. Now angle E, if you see, we got it as 100 degrees, so it is going to be here 0 and 0. So this is going to be the password. Mathematician determine the password means this is going to be your password set by the mathematician. Now, other than your 9 theorems, this is called intersecting chord theorem. This is also equally important. What does it say here? If you'll see the two intersecting chord theorem, this is also another chord theorem that you will see in some of the question. It says that intersecting chord theorem, A, B, C, D are the 4 points, right? So A, B and C, D chord are intersecting at X internally, and in this figure AB and CD intersect externally, right? So how do we get it here? You need to remember this relationship, but how do we reach to AX times here? If you will see here, AX times BX is equals to CX times DX. Similarly here, also AX times BX equals to CX times DX. How do we do it here? Here you use the similarity. Here if I join these 2 points, you can see that here I got two triangles and here join B to C, and here if I take it here C to D. So your triangles are going to be here A AXD and here BCX. So how do we do it here? You know that angles on the same segments are equal. So angle A will be equals to C. Here also this angle will be equals to this angle, right? And similarly, how these two triangles are going to be similar here. AX, so one is this big triangle and another one is this big triangle and another one is this small triangle. How can we show that? Because here it's very easy. You can get here vertically opposite angles are equal. So all the three corresponding angles are equal. That means both the triangles are similar. So I can write down here triangle AXD will be similar to triangle. A corresponds to C, so CXB. How do we get it here? If I take this angle as A, right? This interior angle, because it's an angle on a straight line, will be 180 minus A. And you know that this is a cyclic quadrilateral. ABCD opposite angles sum up to 180 degrees. So this angle will be A. So you can see that this angle B is equals to angle D. Similarly, angle A will be equals to angle C, right? So if I take the triangle there also, it will be triangle AXD will be similar to triangle here. A corresponds to C, so it is CXB. Now, the moment you say that the corresponding angles are equal, that means the corresponding sides will be in equal ratio for the similar triangle. So I can write down here AX by CX will be equals to XD by XB. If you do cross multiplication, I'll get AX times here XB will be equals to XD times CX, right? And if you rearrange, it's the same result here. AX times here bx will be equals to cx times dx. So this result, whether you use internally intersecting chords or externally, you can use it. Only you need to choose the correct triangle. Now what happens in the second figure, if you'll see, there is this called tangent chord theorem. Here both the line segments were chord. Here one of the tangent and one line it is a chord. So you can see in the figure that xt is a tangent and XP is a chord. So how do we do it here? Also, we have to prove that how, because we can't use here similarity. So I can take it here. O is the center. You know that tangent is perpendicular to the radius. So this is 90°. Now to get the result, I have to draw here also 90°. And you know that tangents, any line segment drawn from the center to the perpendicular drawn from the center to the chord bisects the chord. If I'm drawing this here, if I write on this as L, OL perpendicular to XP or PQ, right? Here OX is perpendicular to PQ chord. So it's going to bisect the chord PQ at L. So here it's going to bisect the chord PQ. Right now here you can join here O to Q and O to X. Correct? What is the result here? PA times PX times QX, right, equals to TX square, tangent square. So we can take here any one side LHS. If I take it here, see, I'm just giving you the proving part. Later on, you have to use only the result, but you should know how are you reaching to that result, right? So Px, that's the full length. If I take it here, I can write down this as XL plus PL, right? Because this total length here, if I take this total XP length is the sum of length XL plus PL, right? Similarly here, if I'm writing the other part QX, because it should be the same thing, so I'll write down in terms of XL only. So XQ is, or QX is going to be XL minus LQ or minus QL. Now you know that here because it bisects, so PL is equals to QL because OL is perpendicular and perpendicular from the center to the chord bisects the chord. So I can write down here XL in this place, PL place, I can write down QL. It will become XL square minus QL square because I have used A square plus minus B square identity. A square minus B square will be A plus B times A minus B. I have used that identity. These two of them are equal value. Still, I have to get it this as in terms of xt. So let us see here xl. If you will see here, we'll use Pythagoras theorem in place of xl. What can I write down here? We can write down here ox square because I'm trying to connect this triangle with this triangle because xt is the part of this triangle, whereas I'm having xl which is part of the other triangle. So we have to do something so that we can relate both the triangles. So here ox square XL square will be equals to OX square minus OL square minus QL square as it is. Now here if I take OX square minus is common, OL square plus QL square. If you see this, look at here, QL square plus OL square is nothing but OQ square using again Pythagoras theorem. So I can write down here OX square minus OQ square. Now OQ is nothing but the radii and you know that the radius is always equal in length. So OT will be equals to OQ. So you can see that we are reaching to the other triangle. This is minus OT square because here OQ is equals to OT. After that, what do we do here? OX square minus OT square. If you see, it is the part of this triangle. Hypotenuse square minus OT square will be equals to XT square. So we will reach to here XT square. So Px times Qx will be equals to tangent square, which is the same result here, Tx square or Xt square. So these results you are going to use to solve the question. So see, this is your one of the investigating pattern question. What is written here? There is a circle, right? In this figure, point A and D are fixed. So you'll see that this point and this point A and D places are fixed. As we move B and C towards y equals to minus 1, that means here y is equals to minus 1. You'll see that in your online assessments, you will see that you will be able to move these lines. What is given here? If you are moving y equals to minus 1 means this is going to be y equals to minus 1. This is y equals to minus 1. If we are moving towards that, similar manner, length L of OD will change. Now OD length, it's taken as here L, capital L, right, as changes, but OA times OB is already always fixed here, which is 0.5. If you see here, this is nothing but there are two chords CD and AB and they are intersecting internally. So you should know that just now we have learned intersecting chord theorem. It will be OA times OB will be equals to OC times OD. This result, we'll see that if we need to use somewhere. Now, what is written here? The following table shows the changes of length L of OD. Now, if you will see here, this is plus 0.02, right? So again, from here to here, if I add it plus 0.02, if we add it, it will be 0.60 units. Then you will get here 0.62 units, and then you will get here 0.64 units and then 0.66 units. So you have predicted the value of L for n is equals to third stage, fourth stage and fifth stage. We have already done this. Each one will give you here 3 marks. It's knowing and understanding. Then after that, describe the pattern of L, the difference between here. In words means you need to write down properly. The difference between any two consecutive, because any term you can take it, okay, between the two consecutive terms, to any two consecutive terms is 0.02 units. Okay, and then full stop. Yeah, this question is done. Your second part is done. Here communication is written. Determine the rule for L in terms of N. Now, how will you relate these two? First place, this, second place, this, third place, this, fourth, and this. So you need to write down L in terms of N, right? So you know that if you will see that this is nothing but write down the values here. This is called stage. If first stage, it is 0.56, right? Here 0.56. Then here second stage it's 0.58, third stage it's 0.60, and so on. So if you will see here, the first difference is same, which is 0.02. That means this is the arithmetic or linear sequence, right? Here 0.62 if we get it. So how are we going to get the rule here? You know that there are two ways to do it. You can use here nth term, which is Tn, nth term. Sometime you write on as Un or Tn here. What can we write down here? If we are writing here, either you use a plus n minus 1 d formula, where d is the common difference, first difference, which is d, and a is the first term, or I can use the standard form a n plus b. This is a is the common term and b is the zeroth term. Anything is fine here. If I do that, then the nth term formula, first term is 0.56, right? Will be, if I use this, then plus n minus 1 times 0.02. If you do the simplification here, 6 plus 0.02 n minus 0.02, and if you subtract this, you will get here 0.54. Right here, if you get it, this is n minus 1 times 0. This as 0.56 plus 0.02 n minus 0.02. So your nth term is 0.02 n plus 0.54. So this is your nth term. Here also, if I use this, a is the common difference, so directly you can get it here 0.02 n plus b is the zeroth term, means it will be here, if I'm going my this one to the left side, it will be minus 0.02, which is going to be 0.54. So this is your nth term formula. For any term, you can use this rule to get the value of any stage. Then after that, if I'm doing this, how are we going to solve this fourth question? It says, find the length of OC for n is equals to 1 up to 2 decimal places. Now, nth term, if you will see here, That's why here we need to find out OD length for the first stage. So OD is already given. We need to find out here OC. Here we can use this intersecting chord theorem because you know that OA and OB product is always fixed, which is 0.05, right? And we need to find out here OC length. So you know that here OA times OB will be equals to OC times OD. Now here OA into OB is 0.5, which is equals to OC length is not known. OD length for the first stage it is 0.56, right? From the table I can use it here. So this is going to be 0.56. So OC length is going to be equals to, here's zero point 0.5 divided by 0.56. If you do it, you are getting it as 0.8928, and till two decimal places, you will take the approximate value as 0.89 units. Right? After that, what is written here? Investigate a pattern for length L of OC. Now, capital L was the length of OD. Here, we need to take small l for OC length in terms of L. And in your answer, you should complete the table, describe the words a pattern for L, determine the rule for L in terms nth term rule, and verify for n equals to 5, and clearly show your work. So just now we got it here. If we are taking this, OC is 0.89 units, right? Here, and the second stage also OA times OB is equals to OC times OD, right? So this is fixed. Now, what is going to be the length of OC in the second stage OD? You see that in the second stage OD is 0.58. So I can take it here 0.58. So this is when n is 2, right? So we will see that what is the pattern we are getting here. 0.58. If I do it here, it's coming it as 0. Till two decimal places 0.86 units. When n is equals to 3, again here OC you got it as 0.86 units. Now again here 0.5 is fixed. OC length we don't know, we need to calculate. And here if you will see, it is in increasing order, right? So it's a 0.60. So here also when we'll take 0.6, which is, so OC will be 0.5 by 0.6. If you take it here till two decimal places, then you will get the answer as 0.83. Now you can derive the pattern, because you can see that here the next fourth term, it is going to be, it's getting decreased by, if you'll see this, it's minus 0.03, right? So it will become 83 will become, if I'm doing subtraction, 80 units. So till fourth term, you need to find out here. You have completed the table. Now describe the pattern in words. So if you will see, if you'll say that what is going to be the pattern here, the difference between consecutive terms is minus 3. So what, the same similar way, how will you write down the difference? Now here difference between any two consecutive term is between consecutive terms is 0.03 unit. That is going to be word. Determine a rule for nth term rule. If I take it here, again I can use here un or tn will be equals to a plus n minus 1d. This is a rule. Or you can use an plus b rule. So I'm using this rule, which is what is the common difference? If you will see here, first term is 0.89 plus n minus 1. Now your d is negative 0.03. Remember that. Okay. So because if you'll change the sign, then your answer will be wrong. 0.03 n plus 0.03. So what is going to be your nth term? If you'll see, minus 0.03 n, and then plus 0.93. This is your rule for n equals to 5. How will you verify? You can substitute for, here n is equals to 5, then you substitute here, tn will be minus 0.03 times 5 plus 0.93, right? If you see that here, if I do this 0.15 minus 0.15 plus 0.93, and if you do the subtraction, you will get here 0. Uh, 0 point here, how much you will be getting? 0 plus 9, this is 92, not 93, because if you'll add it here, it is going to be 92, not 93. And this is also 92, this is negative, right? So 0.92 minus 0.15, if I do it, I'll be getting here 0.77 nth term value, which is so. And how much is this? If you verify means you need to write down here also what is the value, because here nth term rule you are using and here you are decreasing by 0.03, so it's 0.77 units. On the table also there will be place given, so you must write down there as well answer, right? So here, which is you have verified here, hence verified, which is uh, 3 less than 0.88. So you can write down also here is 0.03 less than what was the value given? 0.80 in the fourth term. From fourth to fifth term, if you're coming, you have to decrease by this. So you have verified this, so it's a hence verified. There is one more bit you have to do it here. If you will see, what is the last bit? If you will see clearly, show your working. So wherever you are doing, wherever you are solving it, make sure you are doing it properly. I hope you got this.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.